Hello everyone, I'm Monica Lai Wing. So today I would solve the question 2B1 and 2B2 in semester 1 2014 to 2015 examination paper. So a survey is conducted by students' office recently to connect the preference of final year students to enroll development program in the next semester. The results show that 90% of the students would enroll an international program. 84% of them would enroll a social development program, and 2% of them would neither enroll any one of these two kinds of program. So first of all, we should highlight the important information that is provided in the question. So the first question would be, what is the probability that a randomly selected final year student would enroll both intellectual development and social development programs? So first of all, we should list out all the information that is provided. The probability of I represent student enroll at international program, which is 90%, and we can say 0.9. And probability of a social program, student enroll a social program is 84%, which is 0.84, and student would neither enroll any one of these two kind of program is 2%. We can write it as 0.02. So the probability of I union S would be 1 minus 0.02 equals to 0.98, which is 98%. This is the number that student enroll any kind of program. So in order to find the answer for 2B1, the solution will be using addition rule. So the probability of I union S is equals to probability I plus probability S minus probability I intersecting S. We can come up with the answer of 0.76 is because 0.9 plus 0.84 minus I union S, which is 0.98. Therefore, we can come up with the answer of 0.76. So the last question would be, what is the probability that a randomly selected final year student would enroll only one of these two programs? The solution would be using the answer we got from previous question, which is 0.76. The equation would be probability of I union S minus probability I intersecting S. Therefore, we can come up with the answer of 0.22 is because 0.98 minus 0.76.
Hi everyone, I'm Chongning Lan. Next, we will be talking about the question 2B part 3. This question is given that a randomly selected final year student will enroll an intellectual development program. Calculates the probability that this student will not enroll a social development program. The word given that implies conditional probability, which is a measure of the probability of an event given that another event has occurred. In order to solve this question, first we have to find out the probability of the student who had enrolled in intellectual development program. The 98% represents the student who have enrolled in either intellectual development program or social development program, and the 84% represents the student who have enrolled a social development program. Then by minus the 84%, we have the probability of student enrolled in intellectual development program only, and the 90% represents the conditional probability. So, which has mentioned before, it is mentioned before. By doing this, we have the 40%, which is coming from here, and by dividing them we have got the answer, which is 0.15555, or by this. Which is 7/45. Next, we will be talking about the question 2A1, page 198. The question is, how many different ways of selecting the chairman, secretary, and treasurer out of the 25 members? It will be 25P3, because there is 25 members and we have to select them by one by one, and which means that the orders of the order is important in these questions. Therefore, we will be using permutation instead of combination. Therefore, it is 25P3. Which is 10,000, 30,000, and 800, which is here.
Hi, I'm Ho Chi Ting Iris. Today I'm going to explain the question 2A, 2, and 3 in mock paper 1. When the chairman, secretary, and treasurer have been selected, how many different ways are there of selecting the 4 other committee members? As the 3 members of the society have already become the chairman, secretary, and treasurer, there are 22 members of the society can be selected to become the 4 other committee members. As the positions of the 4 committee members are same, the order of the selections does not count. We can use combination to finish this question. Therefore, the number of ways of selecting the 4 other committee members is 22 combination 4. So the answer is 7,315. Question 3. How many different committees can therefore be formed from the 25? We have already known the number of ways of selecting the chairman, secretary, and treasurer in question 1, and the number of ways of selecting the 4 other committees members in question 2. To finish this question, we just need to multiply the answer of question 1 and the answer of question 2. So it is 30,800 multiply 7,315. And the answer is 100,947,000.
Hi, I'm Kavina. Today I'm going to explain question 2B in mock paper 1 to you. So there are 3 members of a private country club that have been nominated for the office of president. So the possibility of Mr. Chan, Mr. Lee, and Mr. Zhang of being elected is 0.3, 0.5, and 0.2 respectively. So there's the possibility of an increase in fees. After that will be 0.8, 0.1, and 0.4 respectively. If someone is considering joining the club but delays his decision for several weeks, only to find that the fees have been increased, what is the possibility that Mr. Zhang was elected president of the club? So the question is basically asking for the possibility of Mr. Zhang being elected, knowing that there's an increase in fees. So by solving that, we can use a Venn diagram to simply explain the question. So the universe will be every situation that the fee is increased. So we separate the Venn diagram to 3 parts. So Mr. Chan, Mr. Lee, and Mr. Zhang. So for this column, it will be the possibility of them being elected multiply the possibility of an increased fee. So to solve it, we can use the Bayes theorem. So we put the possibility of Mr. Zhang being elected, knowing that the fees are increased. So we put Mr. Zhang, the possibility of him being elected, and the fees are increased over every situation that the fees is increased. Therefore, we will have an answer of 0.2162. This is a simplified one. This one is like the original answer. Thank you.
Hi, my name is Lai Weilin. I'm from Group 2. I'm going to talk about mock paper exam 1, question 2C. 8 pairs of twin brothers participate in a forum. If 6 of them are selected at random to form a group for further discussion, what is the probability that there is exactly one matching pair of twin brothers among the 6? So these are the 8 pairs of twins. I separate them by different colors because they are all different people. Our goal is to select 6 people randomly and calculate the probability that 2 of the 6 people selected are a pair of twin brothers. So the formula will be like this. And in the bottom part, we have to calculate the combination of 6 randomly selected people. And in the upper part, we have to calculate the combination of 1 matching pair of twin brothers, and then the rest 4 people are from 4 different pairs of twin brothers. If we want to select 6 random people, we have to write 16C6 because there are 16 people from the 8 pairs of twins, and then the 6 are the ones we want to select randomly. And the 1 matching pair of twin brothers, it will be 8C1 because there are 8 pairs of twin brothers, so we want to select 1. And the 4 people from 4 different pairs of twin brothers, we know that there are only 7 pairs of twin brothers left because 1 pair is already selected by this 1 matching pair of twin brothers. So we have to select 4 from the 7 pairs. So it is 7C4. And we have to times 2 power 4 because in each pair of twin brothers we selected, it might be the white one or the yellow one. So it means that for each pair of twin brothers selected, there are 2 possible results. And it goes like this. And then if you calculate this formula, the answer will be 0.559.